Right, so we have another question on the board, and it says the gravitational force between two objects of masses 10 raised to power 24 kilogram and 10 raised to power 27 kilogram is 6.67 Newton. Calculate the distance between them. We are given the gravitational constant as 6.67 times 10 raised to power minus 11 Newton meter square per kilogram square. Alright, so we are looking at these two objects. We assume that these objects are spheres, okay, and this is the second one. Now the mass of the first object, m1, was given to us as 10 raised to power 24 kilogram, 10 raised to power 24 kilogram, and the mass of the second object, m2, was given to us as 10 raised to power 27 kilogram, 10 raised to power 27 kg. All right, okay. All right, and then you also see here that the distance between them was not given. We asked to calculate the distance between the both objects, okay. This is their center, so their distance apart will be r. Their distance apart is r, and it is not stated, it is not given. Now the force of attraction between these masses, is was given to us. The force of attraction was given to us as 6.67 Newton. 6.67 Newton. That is the force of attraction between the both masses. 6.67 Newton. Right? The force of attraction between the both masses is 6.67 Newton. Okay, so we continue. We then go to the formula. However, also note that the gravitational constant was given as 6.67 times 10 raised to power minus 11 Newton meter square per kilogram square. Okay, it was given here in the question. Alright, that's the gravitational constant. Then you go to the formula from Newton's law of universal gravitation. From Newton's law of universal gravitation, we're having that F is equals to G m1 m2 G m1 m2 over r square. That is Newton's law of universal gravitation. Okay, and we're going to make r the subject of formula. If I cross multiply, I'll be having f r square equal to G m1 m2. Why? Because this one has a denominator of 1. This f has a denominator of 1. So if I cross multiply this, we'll multiply this, and that is G m1 m2, and f we multiply r square, and that is f r square. That is when I cross multiply. If I cross multiply, okay, so f times r square gives me f r square, and then gm1 m2 times 1 gives me gm1 m2. So if I divide both sides by the coefficient of r square, this changes to f r square divided by f is equals to gm1 m2 divided by f. So f will eliminate f, and I'll have that what? r square is equal to gm1 m2 over f. Now we then take the square root of both sides. Taking square root of both sides, this is r square all raised to power half equals to g m1 m2 over f all raised to the power of half. So this will eliminate this, and I have that r is what? The square root. R is the square root of g m1 m2 over f. Okay, square root of g m1 m2 all over f, the force f. Okay, so this now will be equal to square root of the value of g, gravitational constant is 6.67 times 10 raised to power minus 11 multiplied by m1 is 10 raised to power 24. 10 raised to power 24 times m2 is 10 raised to power 27. 10 raised to power 27 divided by r is f. The force there is 6.67. 6.67. Okay, so this is what we are looking for. We're looking for r, and r is the square root of g m1 m2 over f. Okay, that is it. So we use our calculator and we find the values of this 6.67 times 10 raised to the power 11, or you say 6.67 exponent minus 11 times exponent 24 times exponent 27 using your scientific calculator. Alright, so r will be equals to the square root of 6.67 times 10 raised to the power 40. Okay, as when you multiply that you have this divided by 6.67. okay, when I do the division, I'll be having, this can eliminate this, and I'll have square root of 1 times 10 raised to the power 40 times 10 raised to the power 40. 1 times 10 raised to the power 40. Now if I find the square root of that, I have my radius as 1 times 10 raised to the power 20. 1 times 10 raised to the power 20 meters. That's the radius, or the distance between them. Alright, so you observe here how we made r the solution formula and I cross multiplied. This times this times this, f times r square, you have f r square, 1 times gm, and you have gm1 m2. Okay, so I divided both sides by the coefficient of r square. The coefficient of r square is f. I divide both sides by f, so this is f divided by f equals to gm1 m2 over f. Okay, now it means that it implies that r square will be equal to gm1 m2 over f. r square equals to gm1 m2 over f. And then you also observe that I took square root of both sides. Taking the square root of both sides, this is r square all raised to power half equals to gm1 m2 raised to power of half. So 2 we cancel out 2, and having that r is equals to the square root of gm1 m2 over f. Alright, so if I substitute into the formula by substitution, g is 6.67 times 10 raised to the power minus 11, which is this, which is what I'm having here. And then m1 is 10 raised to the power 24, and m2 is 10 raised to the power 27. So if I multiply this now, multiply everything, as 6.67 exponent minus 11 times exponent 24 times exponent 27 divided, okay, if you multiply it, I'm having 6.67 exponent 40. 6.67 exponent 40. So this will cancel out this. I'll have 1 exponent 40. 1 exponent 40. And the square root of 1 exponent 40 is 1 exponent 20. So my distance apart, the distance apart is 1 exponent 20 meters. Alright, we have another question on the board. It says a planet has mass m1 and is at a distance r1 from the sun. Okay, a second planet has mass m2 equals to 10 m1 and is at a distance of r2 equals to 2 r1 from the sun. Alright, so they say determine the ratio of the gravitational forces experienced by the planets. The options are A, which is 1:5, B 2:5, C 3:5, and D 4:5. Okay, so we look at that. The planet has mass m1. So for planet 1, say for the first planet, this is the planet, and then this is the sun, and this is the sun. Okay, so this is the sun, and the mass of this planet is m1. The mass of the sun is ms. Okay, now this is their center. However, we are told that it has a distance r1 from the sun. So distance between this planet and the sun is r1. The distance is r1. That's the distance between the first planet and the sun is r1. Okay, alright, and then we are told about the second planet. It says the second planet has mass m2 equals to 10 m1. Okay, so for the second planet, we say the second planet we are looking at this. It says this is the diagram of the second planet, and then this is the diagram of the sun. So we are told that the second planet has a mass m2. The mass of the second planet is m2, which is equals to 10 m1. Okay, this is the sun, and this is the second planet, the first planet, and the sun. Alright, so and the mass of the sun is ms. The mass of the sun is ms. Okay, now we are also told that and is at a distance of r2 equals to 2r1 from the sun. So the distance of the second planet from the sun, is r2 equals to 2r1 from the sun. Okay, so distance of the second planet from the sun is 2r1. So r2 is equals to 2r1. The mass of the second planet is 10 times the mass of second planet is 10 times the mass of the first planet. And the distance of the second planet from the sun is 2 times the distance of the first planet, r1, from the sun. Alright, so take note of that. Then we'll proceed. Alright, so we know that from Newton's law of universal gravitation, we know that F is equals to G m1 m2 over r square. Okay, that is Newton's law of universal gravitation. Okay, so we'll now look at this the first planet with respect to sun. First planet with respect to the sun. That means that mass m1 here will be the mass of this planet, and m2 will be ms. Alright, okay, so that means f1 will be equal to g. My m1 here is this planet, the first planet, and my m2 will be ms. Okay, that is g m1 ms over r1 square. Okay, so that means that the first planet with respect to the sun, using Newton's law of universal gravitation, is you have F1 being the magnitude of the gravitational force. F1 will be equals to G m1 ms. So that means that m1 here represents the mass of the first planet, and m2 here will represent the mass of the sun. Okay, so we have this is m1, and then this is the mass of the sun here. Okay, so these are the two masses, the 2 point masses, the mass of the first planet and then the mass of the sun. Alright, and then their radius, which shows the distance apart. Distance between the first planet and the sun is r1. Okay, now we can then make the gravitational constant subject of formula. When I cross multiply, if I cross multiply, I'll have f1 multiplying r1 square. By cross multiplication, we have this, and then this will come down because this has a denominator of 1. So I'll have g m1 ms multiplied by 1, and I'll have this is g m1 ms will be equivalent to, you have the force F1 multiplied by r1 square, which is F1 r1 square. Okay, so if I then make g the subject of formula, I have that g will be equals to F1 r1 square all over m1 ms. Okay, all right, so I can call this equation 1. Equation 1 is F1 equal to G m1 ms over r1 square. That is F1 equal to G m1 ms over r1 square. This is the first equation. So I made this the subject of formula. I can call this equation 2 if I want. Then we'll look at the second planet. It's a second planet with respect to the sun. Second planet with respect to the sun. that is F2 will be equals to G M2 MS over R2 square. Okay, all right, so that is it. So it means that this is the second planet, the mass is M2, and this is the mass of the sun. All right, so second planet with respect to the sun, and their distance is what? R2. However, we are told that M2 is equals to what? 10 M1. So we'll put it there, and then R2 is what? 2 R1. So this equation now will change. To change to, say, F2 equals to G times what? M2 is what? 10 M1, right? Times MS over, and R2, we had the value of R2 as what? 2 R1. 2 R1 all raised to power what? 2. Okay, so the value of M2 is this, is 10 M1, and R2 is what? 2 R1. So if I square this now, I'm having that F2 is equals to G times this, so that is multiply everything, you're having 10 G M1 MS over 2 raised to power 2 is 4, and then R1 raised to power 2, that is R1 square. Okay, that is it. So this is G times 10 M1 times this, that will be 10 G M1 MS. That, and then 2 raised to power 2 give us 4, and R1 raised to power 2 is what? R1 square. So I can call this one my equation, and call this my equation 3. Okay, all right. So if I then substitute equation 2 into equation 3, I substitute equation 2 into equation 3, I say substitute equation 2 into equation 3. So that means equation 2 is this. Anywhere I see G, I'll write F1 R1 square over M1 MS. So I'll put it here. In place of this G, I'll write that. So the equation changes, and I'm having F2 equal to, in place of this is 10 times, in place of G, I'll write F1 R1 square over M1 MS times M1 MS over 4 R1 square. Okay, so this is it. So you see that equation 2 changes to equation 3 changes to 10 times F1 R1 square over M1 MS times M1 MS over 4 R1 square. So you can then eliminate this. We eliminate this, okay, to cancel out, and then you also observe that R1 square will eliminate R1 square, and you'll be having F2 equal to 10 F1 divided by 4. Okay, so F2, so we have that F2 will equals to 10 F1 divided by 4. Alright, that's it. 10 F1 divided by 4. And you also observe that 2 can go here. You have 2. 2 going to 10 is 5. Alright, so I have that F2 equals to 5 F1 over 2. Okay, so of which, if I cross multiply, I'm having 2F2 equals to 5F1. Okay, 2F2 equals to 5F1. And the ratio of F1 to F2 will be the ratio of F1 to F2 will be equal to 2 over 5. Okay, this is equal, the equivalent to F1 ratio F5, F1 ratio F2 rather, is equals to ratio 2 is to 5. Final answer. So that is it. This is it. So when I cross multiplied 2 times F2, I have what? 2F2. 2F2 equals to 5F1. Alright? 2f2 equal to 5f1. And then I then converted it to fraction such that this fraction is similar to this linear equation I'm having here. Okay, so that is, when I still cross multiply, f2 times 2 gives me what? 2f2, and f1 times 5 will still give me what? 5f1, isn't it? Alright, so f1 over f2 equals to 2 over 5, which is converting to a ratio. That's what? f1 ratio f2 is equals to 2 is to 5, ratio 2 is to 5. And my answer is option B. Option B is my final answer. Okay, so we have to determine the ratio of the gravitational forces experienced by the planets. That is ratio 2 is to 5. And we solved that. We got f1 ratio f2 as 2 is to 5. So briefly, I'll just explain this. This is the first planet, and the mass is m1. The second planet, the first planet with respect to the sun, the mass of the sun is ms. Okay, over there, and the distance between the first planet and the sun is r1. And look at the second planet. The mass of the second planet is m2. We say m2 is equals to 10 m1, and the mass of the sun is what? ms. Right? The distance between the second planet and the sun is 2r1. So the distance between the second planet and the sun is r2 equals to 2r1. Okay, take note of that. Now we're making use of Newton's law of universal gravitation, and the formula tells us that the gravitational force of attraction F is equals to gm1 m2 over r square. Okay, now we are looking at this in two scenarios. The first scenario is the first planet with respect to the sun. Now that means that this will be the m1 there is the mass of the first planet times ms is the mass of the sun, all over r1 raised to the power of 2. And r1, I told you, is the distance between the first planet and the sun. So distance between the first planet and the sun is r1. Okay, alright, so that's good. So we then made the g subject of formula. If I cross multiply, I'll have f1 times this, that's r1 square, gave me f1 r1 square, and that gm1 ms will come down to multiply denominator of 1. So this multiplied by 1, I'll have a gm1 ms. So divide by the coefficient, dividing by both sides by m1 ms, I have that g, my gravitational constant, is equals to f1 r1 square all over m1 ms. Okay, that's equation 2. So we look at the second planet with respect to the sun. Okay, so the force of attraction F2 will be equals to g m2. M2 is the mass of the second planet times the mass of the sun all over r2 square. Okay, so that is it. The mass of the second planet times the mass of the sun. The mass of the sun is this ms. Okay, this is the mass of the second planet. So I have that. So, and also we remember we are told that m2 is equals to 10 m1. So in place of this m2, I'll write what? 10 m1. And we also told that r2 is equals to 2r1. So in place of this r2, I'll write what? 2r1, all raised to the power of 2 is raised to the power of 2. Okay, so 2 raised to the power of 2 is what? 4. And r1 raised to the power of 2 is what? r1 square, isn't it? Okay, so by having that, my f2 is equals to 10 gm1 ms. That's when we multiply. G will multiply this and this. So that will give us what? 10 gm1 ms. That's this. I call this one equation 3. Then I say substitute equation 2 into equation 3. That means in place of this, anywhere I see G, I'll write what? F1 R1 square over M1 ms. So if I substitute it there, the equation changes. It changes, and I'll be having, in place of this, my G now, I'll write this. That is F1 R1 square over 10 M1 ms. So this is 10 times the value of G, that is this one. So the value of G is this one that is here. So R1 square, we cancel R1 square. M1 ms, we cancel M1 ms. I'm left with what? 10 F1 all over 4. Right? So that is it. I'm left with 10 F1 all over 4. So 2 can go into 4. 2 going into 4 is 2. 2 going into 10 is 5. So F2 is equals to 5 times F1 is 5 F1 all over what? 2. So I cross multiply 2 times F2 gives me 2F2 equals to 5 F1. So when I convert to fraction, I have F1 all over F2, okay, is equals to 2 over 5. Alright, so this is equivalent to, in the ratio form is F1 F1 ratio F2 equals to 2:5. So that's the final answer. The ratio of the forces is 2:5. Okay, so that is it. Take notes. Right, please do well to like the video and also to subscribe for more interesting educative videos like this. Once again, I'm Prosper Nnodi. Thank you very much. Thank you.